Yeah, we gotta start and 1 minute later. Yeah, you can check your slides. Is there anything wrong?
I think everything is done. We can just wait for another minute.
Yeah. Um, okay, so I think we'd like to start. And hello everyone, welcome to SGLang's bi-weekly meeting. As a matter of fact, just as we said in our YouTube and in our Twitter, if there's no specific topic to report in each meeting, we won't uh, we won't write Twitter, but just make it regularly. But if we write Twitter to calling for collaborators and calling for people to come, there's definitely something interesting we want to share. And today we'd like to invite each one from UC Berkeley and from MC's Oregon to share his latest research on scheduling systems of building on SGLang. So let's welcome each one, and you can go it for yourself.
Yeah, thanks, Chen Yang, for the introduction. Yeah, I'm Yichuan. So today I want to introduce some recent research work done with LMCs. We will study the scheduling problem, like consider the locality, load balance, and the fairness issue in the SGLang scheduler. And this is the work done with the great LMC guys. Yeah, so today's outline is that I will first introduce some background and the motivation of this project, and I want to go through the detail of DLPM and its distributed version, double DLPM, and we will then go to the evaluation part and the future work. Yeah, let's first talk about the motivation and the background. So why we failed on some case like in the today's SOTA serving schedule and how we can solve that problem. Yeah. Uh, the first part is I want to introduce the fairness in ALM serving. So what's the fairness in ALM serving? The scenario is that there is a server that is serving multiple users concurrently. Assuming the server's capacity is limited and it cannot serve infinite number of requests. So right now, considering in a scenario, there is an overloaded user A, that is sending requests at a very high frequency, and there is a underloaded user that is sending requests at a very low frequency. So the
哦，哈哈，
user
哇，还有字儿呢，哈哈哈。
if we just use some FIFO strategy, so the user B will be uh, if there is something wrong. Yeah,
Nothing. Yeah, it's
nothing.
okay.
Okay, it's okay. Okay. So if the server did not distinguish and only randomly choose the request to process, the user B will be unhappy. So they will not be like served immediately. And in this scenario, the user B gets starvation, but since it only sends a few requests, it should not be delayed. So the design is undesired. So one very simple way that maybe OpenAI uses is just to use rate limit, like limited the rate of request of user A. But that will cause another issue is that if if we just simply limit the request rate of the user, if user A is limited and the user B no longer send any other requests, at this time the server will underutilize. So this simple rate limit method cannot be work conserving, which is not ideal. So there is one very simple scheduler that is done by Ying, which is public in last year's OSDI. This this can perfectly solve the issue, and the scheduler is actually very simple. So every user will have virtual counter whenever scheduling, and we schedule the user with the lowest counter first. We will update the counter and the schedule request at the token granularity. So the counter will be updated according to the cost per token. So in this case, the scheduler always choose the user with the least counter, and this can ensure fairness in the serving engine, and every user will be happy about this. Yes, this is the background of fairness in the serving. And another background is that the prefix catch, which is more familiar to everyone. For example, in popular application like tree of thought, MCTS, and maybe multi-turn conversation, there is a significant prefix sharing within a program.
我就
So
我
the
喜
red
欢什么也是。
the radix attention structure of SGLang will automatically store the program's prefix information, and as the agents or some workloads become much more popular, the prefix sharing pattern is more and more important. However, due to the limited GPU memory, the radix tree will also evict prefix that have not been used for a certain of time. So it will cause some data locality issue like the traditional OS system when dealing with a large amount of concurrent LLM program. Yeah. So SGLang use some technical to increase the data locality, or to say increase the cache hit rate. But the problem is that the fairness problem can be even more severe in this scenario, because like we will first introduce the cache-aware scheduler in SGLang. So in every schedule step, we will like pick the longest prefix match request according to the current KV cache status, and but it will prioritize the locality and increase the throughput, but it can make the fairness issue even more severe. Like imagine a case when a user continually send the long request with the same long prefix, and it can easily be served. The starvation problem will be more severe than first come first serve. So it's easier for malicious user to attack the server, and it can cause many problem like head offline problem, and then make some normal user unhappy about that. Yeah. So here we come to the conclusion of the motivation. Like the LPM will prioritize the request with the longest prefix according to the current KV cache status, which is perfect to locality, as it can increase the cache hit rate and increase the throughput, but it fails to consider the user level fairness. So as we can see from the figure here, the LPM falls into the top left part of the figure, which means it can achieve a good throughput while very poor fairness guarantee. And for the VTC, as we said before, like it can have strict fairness guarantee, so it has a very good J index of which represent the fairness, the service fairness, but it will change the optimal order of LPM, and the KV cache will swap in and swap out, like in the GPU memory. So it's prioritize the fairness, but like do not carefully consider the locality issues. So it's good at fairness guarantee, but fails to have a very good throughput. So it like falls into the right bottom of the figure. So our method can achieve a new Pareto frontier, considering the efficiency and the fairness trade-off. And we have a hyperparameter queue that can be turned to smoothly transfer the server from fairness-oriented mode to like efficiency-oriented mode. Also, from this figure, we can see like if we want to achieve the same level of throughput, our method can gain some like free lunch in terms of the fairness index. And if we want to like have the same level of fairness guarantee, we can also compare to VTC, we can also gain some free lunch in terms of the throughput. So here we just have a very simple but effective method to achieve a new Pareto frontier, considering the fairness and the uh, locality. Yeah. So if you guys have some issue here, yeah, maybe we can have some discussion here. I can't wait for, yeah. Not, we can go to the next part. Yeah, here I want to simply talk about the algorithm of DLPM and its distributed version double DLPM. Yeah, for DLPM, yeah, it's as I talked before, it's a rather simple but effective method. We just borrow some idea from the traditional OS called deficit round robin, and which means every user will meeting a quantum. The quantum is the Q, the hyperparameter I talked before. So we will first iterate along the LPM order, and if we encounter we will first sort the request in a LPM fashion, and when we encounter a request, we will check whether the quantum of that request, like every user have a quantum, and the request is sent by a user. We will check if that user's quantum is larger than 0. If it is, we will just schedule that request and decrease the quantum. And if not, the quantum is less than 0, we will simply skip the request. And if we have a scenario that every user's quantum is less than 0, we will then like compensate all of the user to this give all of the user the same quantum. Yeah. So basically, the idea is we have some locality buffer that in the LPM fashion, and this is a very simple scheduler that can easily be deployed on SGLang and even other like serving engine. And as we talked before, it can achieve a good performance. Yeah. So this is the single machine scenario. As for the like multi GPU scenario, when we consider the data parity in LMPN, in this case we can also extend the DLPM to its distributed version, double DLPM, which can also ensure global level fairness guarantee, but the algorithm may be a little bit like more complex. So we set another quantum based on the we set another quantum-based mechanism in the global scheduler, which can make the double DLPM like a little bit complicated. But like from the high level idea is that in the local GPU, we still run DLPM, and in the global level, we use a central radius tree to achieve locality, and use per user per worker content to achieve fairness and load balance. Yeah, if some people are interested in the detail, maybe we can talk it more in the discussion part, but it's like somehow complex. So because the time is limited, I will just skip this part. We will then go to the evaluation part. Yeah, yeah. For the evaluation of these two scheduler, or say the system we built, just consider both locality, load balance, and fairness. We test the system with this diverse workload, like long context question answering, as jar tree of thoughts, multi-turn conversation. We like represent the killing applications recently. And our evaluation config is that we mimic some malicious user that maybe send more requests, or send requests that had a truly like longer prefix. And our model using here is like Llama 3. Yeah. And the baseline here is the BTC, the algorithm that consider fairness but ignore the locality and the load balance something. And the LPM just considering the locality, but they do not consider the fairness issue. And the Primble is a scheduler that consider both locality and load balance. It's load balance and the locality are well routed from the global perspective. Yeah. Yeah, here is the results. We will show the effectiveness of our method from like the throughput, fairness, and the victim user latency, these three perspective. As we can see from the first column, is represent the throughput of every scheduler. We can the double D LPM can always be the best in terms of throughput, maybe fill in one or two data points, because we will sacrifice some efficiency to the fairness. So in some in just two data point, we may be a little bit worse than the Primble. And as for the fairness, as we can see, we can always achieve a better fairness, Gen fairness index compared to LPM and Primble. As I talked before, we will like sacrifice a little bit fairness to achieve a uh better performance. So the fairness guarantee is worse than VDC, but we can say it's almost the same. Yeah, the last two laws consider the P50 latency and P99 latency. So as we can see, our method can always be the best. It's the lowest part. The red column is the double DLPM. Yeah. Do you have some questions about this evaluation results? If not, yeah, maybe we can come back later. Yeah, here is some case study. We like investigate deeper into the user latency and the user like the throughput in one certain workload. This is the workload like there are several clients that send tree of thought program, but client client one send the tree of a very larger tree of thought program. You can imagine it's the same D, but it has much more branches. And we can see from the first row, double DLPM, our methods can always achieve a better user latency. Round robin and LPM and the Primble, the last two one, because they do not guarantee fairness, their user latency is very high. You can see the client one and the client two's user latency is very high because the server just prioritize serving the client zero, and the client one and two will be very unhappy about this. Like they have like 600 seconds user latency compared to just like maybe 20 in the double DLPM. So in terms of user latency, we can make sure everyone is happy about their service. And in terms of throughput, like we can see from the y-axis, it's the end-to-end execution time of the program, and the double DLPM is always the best, nearly 2 times throughput gains compared to some other scheduler. And the one very interesting part of like the Primble is that we can see, even though Primble consider the locality and the fairness issue, there's even though the Primble consider the fairness locality and the load balance issue, its performance is still very bad considering the throughput. The reason is that client one and because it's a tree of thought program, if we cannot generate more requests, like our requests in the lower level of the tree is not get served, we will not generate more requests. So because of that data dependency issue, the client one and the client two cannot generate more requests, and the server just served the client zero because the server just consider the locality issue. So the client one and the client two will be like the fairness issue will be even more severe here. Yeah, this is a case study, and we do some ablations, considering some other problem people may be interested about the scalability issue that we increase the number of clients. Our method can always match the performance of LPM, and the VDC always have a very low cache hit rate because the KB cache is always swap in, swap out, like between the GPU. And we also do some mix of workload. We put LM, SGLang, monitor conversation, and tree of thought together. We can see the same figure here, like the DLPM can always be the best in terms of user latency, as we can like easily identify from the first row. Yeah, the user latency is always very low. Yeah, so here comes to the conclusion and the future work. So the conclusion here is that we introduced the first locality aware fair scheduler, and this algorithm is called DLPM, which can maintain a very high degree of prefix locality with a strict fairness guarantee. As I talked before, we have strict fairness bound. It's like from the mathematical perspective, so no method can attack the fair scheduling, like the scheduler, and we can easily extend it to its distributed version. And for the future work, we will gradually upstream to the SGLang code base, and more follow-up research direction include sharing prefix among users, and within users request level fairness guarantee, and also considering the data dependency, like in agent workload or much more complicated LM program, the fairness problem can be more complex in this workload when we carefully consider the data dependency. Yeah, that's it. Yeah, that's it. Thank you.
Okay, hi, John. I have a quick question regarding your last page. Could you move it back? Yeah, one page. You have said that there's something like the data dependency problem in agent workflows. Could you illustrate what kinds of dependency it is and what's the difference between scheduling one single request and scheduling
Yeah, yeah.
several
Okay.
agent
Yeah, yeah.
workflows?
Yeah. It's a very good question. Like you can imagine in an agent workload, if you do not like execute one request, then several requests like that has the dependency after that request cannot be executed, right?
Yeah.
Yeah, if we like that will make the fairness problem much more complex. Whether it if like maybe it's like m much more like emergent request, we can say that in but from the maybe our fair scheduler will not schedule that, but it can get much more throughput gain if we like prioritize the request which high degree of dependency after that. So so uh, do you think I clarify on this problem? Like
Yeah, I think it's clear. So, in my naive thinking that, I think that one thing may be useful in agent workflow scheduling is something like you have to make a predictor. Like the
yeah,
scheduling system in Mooncake, they have a predictor to give an input. They just predict the output length, but they do not actually inference that out.
yeah,
So
I know.
yeah,
Yeah,
uh,
it's a different problem, I think. Like predict the output length and also like for agentic workflow, you have the agentic graph. You have already know the execution pattern. Uh,
mm, yeah, but inside that graph, are there any loops that you do not know sorry, when it will exit from that loop? So it will inquire something like a prediction. Like in a loop, it will loop for 3 times, or in other cases, it's quite complicated. It will loop for five
That
times.
will if we considering the loop time, that will make the problem much more like complex. Yeah.
Um,
And also one considering if not considering the fairness problem is it's very complex. If we take the fairness into account that two user have two program, it that will make the things even more complex. That's my point.
um, yeah, since yesterday several somehow like startup founders they discussed about the thing that this year the for visual language models routing system it could make such a thing. So I'm thinking about what we can do and maybe we can discuss that later and we can call for collaboration on this part. Yeah, I
Okay,
think that to
sounds
be
good.
pretty interesting. Yeah.
Okay,
Okay.
sounds good. Yeah.
Yeah. Um, and also, do you take into consideration of prefill and decode disaggregation? I mean, in your system, you just think that a DP router could fix and somehow could solve the whole problem in its own engine. But anyway, we are developing the PD disaggregation. So maybe this engine
Yeah,
will
I know.
just do prefill and yeah, send PB out. So could that make a big difference?
I think like if we just considering the prefill stage, the problem are the same. Yeah.
Okay. Okay. Yeah. Okay, that's my question. And is Byron here? I think Byron, maybe he's pretty familiar with this project. And do you have any, somehow like, do you have any um, plan or motivations to build our next stage router here? Hey, Byron, are you here? Oh, let me check. Okay, we're seeing that Byron may not be here today, but yeah, saying that for SGLang project, we have different routing targets to serve these days, and we are implementing PD disaggregation. So if there's someone, I mean, among the listeners, do you have any interesting idea about PD disaggregation and about routing system? You can directly reach out to us. Yeah, and thanks for coming to today's talk. And anyone have few further questions for this pretty job. Yeah.
So is anyone had like further question about this, or I will like stop sharing the screen and like maybe no.
Yeah. Yeah. The time is pretty concise, right? We have just we directly make it half an hour.
Yeah,
Okay.
okay. I will stop
Okay.
sharing and you can. Yeah.
Okay. Yeah,
Okay.
great work. Yeah,
Yeah.
so the
Thank you.
left yeah, the left time we are going to for a free discussion today. Do anyone have some coming up questions to reach out? Oh, okay.
Hey, yeah, hi. Yeah, it's a great talk. I think, yeah, for the following half an hour, we will just be there, like an office hour. Yeah, if you have any questions, you can just bring it up and we will here to discuss.
Yeah, personally, I have a question regarding visual language model part, specifically for VRL and for OpenRTF. They are discussing about the visual language model supports in their frameworks. And somehow in an extreme mode, they want to say that they will make a separate repo for visual language models, since they think that unifying visual language model together with language models in single repo could be something like tedious to read and uh, to check. So do you think that what's our plan for visual language model, and in what case do you think we can unify these kinds of visual language models?
So I missed your first part, like who is separating the repo?
Yeah, for OpenRTF, one researcher told me that he may wants to make a new repo called OpenRTF -v. Yeah, so specifically for visual language models. I don't think that we should have to make something like SG Vision, but
I
yeah,
see,
you
I
know the
see.
point.
Okay. I see. Oh, is that OpenRHF? I see. So OpenRHF, they want to separate. I don't think they need to separate. I guess they only need to like maybe accept some embedding as input and then do some pre-processing. Maybe that's easier. Okay. Yeah, for us, we probably don't want to separate. Yeah, we will never separate the repo, I think.
Yeah, okay, so yeah, for the visual part, yeah, we do have some plan for this, and for VRL, they also want to implement a visual language model alignment framework. So we are going to make this.
Okay.
Yeah. I don't think that there could be since directly different, but we are going to say, and we are calling for more collaborators um who will take over visual language model. Yeah. Yeah. And that's my question.
Yeah, someone asked about a question about DeepSeek V3 MTP. Yeah, it's called Nexon, and like the algorithm is the same as Eagle, and SGLang has supported Eagle, but the problem is with Eagle we only support that with Flash Infer backend, but for DeepSeek MLA we have to use Triton backend, and for Triton backend it does support a custom mask, which is something required for speculative decoding. So I guess we are still working on that. Do you have any specific questions? Yeah, if you are interested in that, you can help us to like support custom mask in the Triton backend. Then we can easily do MTP for DeepSeek. we don't have a ticket or PR for that. You can run our ego code and then port the custom mask to the Triton backend. Yeah, so we can open a PR ticket for, we can open a ticket for that, like tell you what's the steps to do that. Yeah, I guess no one is actively working on that. So if you want to do that, you can help.
Hey, Liaming, this is Ata. I had a question regarding the in-batch delay scheduling. I remember you added a benchmark with a script that's saying that how the delay scheduling should improve the performance. I'm sending the link to the PR that you sent. So someone commented that. So I tried to reproduce those results that you put in the PR. Someone already commented that the send all batch, the performance is actually even better than the other two with hint. I also using Llama 3 HB on a single H100 could reproduce those results. So the performance is already pretty better. I wanted to see if you have any thought on that or not.
I see. So you also reproduce that one?
Yes, using Llama 3 HB on a single H100. So if I remember correctly, the numbers were like test send all was like 1.9 second, and then the rest were 2.8 or 3 seconds for me. So I was thinking maybe it's very model and hardware dependent. The reason was that I also have a draft PR to improve that further, but since the results that you mentioned were not reproducible, I was not sure if I should continue or not. But regardless, I would appreciate it if you can take a look at this draft PR that I sent as well.
Okay.
Yeah.
Yeah, I was reviewing the draft PR.
Yeah, I will try to reproduce the results that the person who commented on your PR, and we can chat further later. Fine.
So like, then what's the latest result with your PR?
Oh, I didn't test my PR because it's I think introducing some bug into the prefill, but even with your benchmarks, I think the premise is not correct. Like the send all is already much better than those. Like if you compare your numbers with the numbers that are commented on the PR, in your PR, you see that the goal that you mentioned is already met.
Oh, I see. I was reading that comment. I think they are testing a very small model, 3B model. So, but I think I'm testing AB model. Yes, the result will vary according to like CPU, GPU, and the model. But yeah, I think for their results, it's mostly because they are using a smaller model.
Yeah, I think my numbers were with 8B as well.
What? So can you share your result?
I can add I can comment on the PR later. I don't have them
Yeah.
right, but I can reproduce them again.
Okay. Yeah, I think my result is obtained with AB on H100.
Okay, I will reproduce them and then we'll let you know. And also, I would appreciate if you take a look at my draft PR as well. How you
Okay,
think?
so yeah, for your job PR, can you briefly explain what does it do?
Yeah, I will update the PR and will ping you later.
Okay, yeah, thanks.
But I can briefly talk about it here is that basically if even within the batch, if you have many prompts that share the same prefix, we schedule as many of them as much as we can fill the running batch. But Sangbin was telling me that you don't need to. We only schedule single prompt from the group that share the same prefix. So I mark the rest of them unschedulable.
Oh, I see. Okay. Yeah. Your change makes sense. Yeah, that's the like one left to-do item we should do.
Yeah, that was the to-do that I wanted to do. Yeah,
I
this stuff
see.
does that. Yeah.
Yeah, I guess it highly depends on a lot of things. Like it even depends on like prefix length, shareable length. Yeah, so I guess there are quite a few parameters we need to tune.
Yep.
Yeah.
Okay. I will update my PR and will ping you then with the numbers.
Okay.
Yep. Thank you.
Okay, yeah, thanks for the question. And also, hey, David, I have something maybe not related. It's related to an issue and also related to collaboration. Yeah, I sent you an issue right now. You can check it. This one, yeah, 2873.
Okay, this one.
Yeah, yeah, I don't know who could make on this part, and yeah, and today Graham Newbig, my undergraduate advisor, he come to me and he said, and in Open Hands AI, they are reproducing sweet bench results on SGLang, but this caused some issue to them and they cannot make it right now. So that would be helpful if we can fix this for their use case. And also, they have a proposal that we can make a joint meetup, maybe March this year in San Francisco. Yeah. So anyway, I got to talk with them later. Yeah, but maybe this issue is more urgent than the collaboration.
Okay, what's the exact issue? It's too long. Do you have it's a known issue, right? It's known issue. I'm not sure. Interesting, definitely extremely, but it can produce.
Yeah, I think the question that he said, with regarding to the structure output, I think maybe probably that we do not have a strict mode, strict mode of generation.
Okay, I probably can take a look later.
Yeah, okay. Thanks. Also, let me think something. Yeah, 2 days before we discussed about the drop, a performance drop on Chainlink VL, VL. Yeah, and we found that it's the problem that the user did not use the right chat template. So that's not the reason on our part. But anyway, we definitely should have something like the accuracy test for visual language models, and we are continuing working on that. Today I have call for collaborators, external collaborators. We will have a discussion after SML deadline, and we can discuss who wants to take this part for longer period. Yeah.
I see. So it's a user error, not a SGLang
Yeah,
bug.
yeah. Maybe he forget to, maybe he just forget to load the chat template, and that's a huge performance drop.
I see. Can we print a warning or do something?
Yeah. At
Yeah,
least that's a quick fix. Yeah.
I think when we load a vision language model, if the user didn't specify chat template, we should just say like raise a warning or raise an arrow, something like that.
Okay, yeah, that could work. Yeah. Let me just yeah, I will discuss this with E and we can add this immediately.
Okay, I think the issue you posted is also a user error.
Oh, really? Okay. I'm not familiar on this part.
Okay, I probably won't fix this. Can you try? Yeah, I would just suggest them to try regex. What's the exact issue? Yeah, just try this instead. Okay.
I mean, you mean use regex instead of choice?
Yeah. I think we should use regex instead of choice.
Okay, so yeah, I gotta give him the pointer to the regex.
Okay.
Oh, cool.
Oh, hi, Lemon. I
Yeah.
have some question. I'm a new starter for this project about the SGLang. I just wonder, do you have any starting suggestion for someone which part should I start first, and is there any paths I can follow to better learn and familiar with the SGLang project?
Okay. Yeah. This is a good question for Chen Yang. He knows all about how to start, how to read the code, contributor guide. Yeah, Chen Yang, can you help him?
Yeah, actually, Jing has been collaborating with me on a single question. Like we want to write documents on the ego illustration. So, my suggestion is that we have multiple of these kinds of good first issues, like writing documents. You can check that we have limited documents, but that's vital. And compared with VIM, our document is really fewer. But somehow their documents is written by large language models, so they do not have accuracy test for their, a strict accuracy test for their documents, but we have reviewers on documents every day. So for beginners, in my opinion, starting with some documents is the best way. First, you can understand how to build SGLang and how to modify tiny codes and how to use it from the beginning. And after using it, you can find that there's definitely so much thing left to do, right? Even though it's quite a huge and great project right now, but we still have multiple things to do. And every part there's a bunch of bugs to fix, right? So I think that the question is, yeah, so the first step may be writing some documents, some basic one or some advanced ones, and later you can find something if you're interested to do, right? Maybe right now you are doing on Ego, and later you found that this kind of speculative decoding is amazing to you and you want to develop more. You can come and chat with us, and we have a group of people working on more advanced speculative decoding, yeah. And we really welcome anyone to join our team. As a matter of fact, instead that if you have a commitment for over 10 hours a week and longer than half a year, I think there's definitely a great collaboration between us. So that's my suggestion. Yeah. Typically, first write the documents, and later, while you are doing this, you can find something interesting to you, and later you can take part on something. Yeah. Today, Shuai also comes to our meeting. Yeah, Shuai has been working with me for over 2 months. Yeah, we're starting building unit tests for the math in our CI, and later, he volunteered to review several PRs and contribute several PRs on constraint decoding. And now he's taking part of the function calling. So I think that's a good example how we collaborate with newcomers. And if you have a long commitment, we will be glad to see. Yeah, thanks.
Yeah, thank you very much, Chiang and also Lianming. Yes, that indeed helps a lot.
Yeah, and also do you find something that you feel specifically interested in right now?
I think not yet. I think I'll just finish the part about the ego documents. I'm still exploring some other parts that the overall backend structure of the SGLang, and they are very interesting. Yeah, and I think
Yeah.
that part is already kind of a mature one.
Okay, great. And yeah, indeed, we also have a collaborator, Xiaotong. He's also working in speculative decoding. Right now, our plan is that we will first build the document for the KV cache management. If you check the codes, if you check the documents for our code walkthrough, there's a to-do list here, and we said we will merge this into our main document after we finish the KV cache management illustration. So we collaborate with a group of people in Chinese mainland, and we want to release that document between February. Yeah, if that released, you can come and check. And KV cache is actually another core part for SGLang, and you will probably feel very, very interested in. Yeah.
Yeah, of course. Yeah, thank you.
Yeah, also, and in the meantime, you can collaborate with Baizhou. He maybe have a lot of things he wants to do on his part for the LoRa and for something like scheduling. Yeah, this kind of thing.
Yeah, cool, for sure.
Okay, cool. Yeah, and thanks for joining. Happy coding. Okay. Yeah, there's not so much people left. And the last minute, maybe we want to announce that for the next bi-weekly meeting, we got to share our progress on RHF frameworks. Yeah, the thing is pretty complicated. Right now, we implementing naive ones for VRL and OpenRHF. Something like we only need to load the model and to do weight broadcasting. Yeah, but in the next version, we will probably launch the hybrid engine for RHF, and we want to discuss like the visual language model alignment, and so much thing. So maybe for this year, my whole workflow will be focusing on for RHF integration. So hope you guys have the love to come, and we gotta have a bunch of people to present their contribution next week. Yeah, I mean, sorry, next 2 weeks. Yeah. Okay. Okay. So if there's no other questions, we got to end our meeting 2 minutes later.
Yeah, probably we can also end now. Yeah, thanks everyone. I will drop.
Okay. Yeah, we got share the we'll share the record later. And thanks everyone for coming. Bye. See you guys next 2 weeks.